This is MEI Statistics Minor, Bivariate Data 2, Correlation Coefficients. 2.1, Calculating Pearson's Product Moment Correlation Coefficient. So, Pearson's Product Moment Correlation Coefficient is a measure of the linear correlation between two variables. When applied to a sample, it is represented by the letter R, and when applied to a population, it is the Greek letter rho. The value of the coefficient lies between -1 and 1, where 1 represents perfect positive correlation, and -1 represents perfect negative correlation. The point in the middle represents no correlation whatsoever. If you're given raw data, all you need to do is input the data into your calculator's two-variable statistics mode and find the value of R in the summary statistics. You can find out how to do this in your computer manual, or if you're still struggling to do so, you can find more help online. Sometimes you might be asked to calculate the product moment correlation coefficient using summary statistics. For instance, evaluate the value of Pearson's product moment correlation coefficient for a sample with the following summary statistics. So we've got the sum of all the x values, the sum of all the x squareds, the sum of all the y's, the sum of all the y squareds, and the sum of all the xy's, and of course the number in the sample. Now look, that looks very daunting, but it's actually surprisingly simple because you're given all of the formulae in the formula book. So in the formula book, you are given the following. So we've got sex, which is defined like that. We have psi, and we have sexy. This should look a little bit familiar to you. It should have a familiar edge to it, and that is because if we calculated sex over n, that is actually equal to the variance of x, or sigma squared x. Similarly for y, it looks exactly the same but with y values. So psi over n is actually the variance of y, or sigma y squared. Sexy, that won't look familiar to you, but you can see it is constructed similarly to this, except it's got a component of x and a component of y in each part. And so sexy over n is what we call the covariance of x and y. So if the big values of one variable mainly correspond with the big values of the other variable, and the same holds true for the lesser values, so in other words, if the variables tend to show similar behaviour, the covariance is positive. If the opposite is true, the covariance is negative. We need these values in order to calculate Pearson's product moment correlation coefficient. R equals sexy over the square root of sex psi. It then, in the formula book, expands it by substituting all the individual parts into it. I think that's just asking for trouble. That is far, far too easy to make a mistake. So I would stick with calculating sex, psi, and sexy, and then subbing them all into this one here. So, our example again, there are all the summary statistics. Here are the formulae. So, I'm going to do sex first, and that is equal to the sum of all the xi squared. That's already given to us, exactly as it is. 149.3 minus, well, the sum of all the x's, those are there, so that's 36.9 squared, over n, which is given there, 10, pop that in the calculator, 13.139. I've done it to 3 decimal places. You should always go a little more accurate than you want your answers to be. So if you're going for 3 sig figs, I would go for 5 sig figs at least. Psi, similarly, it's the sum of the yi squareds, which is that one. So that's 834 minus the sum of all the y's squared over n is equal to 292.304. Sexy. Sum of the xi yi's is down here, 303.4 minus the sum of the x's times the sum of the y's, 36.9 times 73.6 all over 10. That is equal to 31.816. Then all we need to do once we've got that is sub into the final formula. So that is going to be 31.816 over the square root of 13.139 times 292.304, which is 0.513 to 3 significant figures. So it was a little bit time consuming. I had to use my calculator, but there was nothing difficult. It was just substituting numbers into a formula. In the next video, we're going to be looking at hypothesis testing using the product moment correlation coefficient.